Okay, so we're talking about inverse trig. When you see this, you're looking at inverse trig. That sign with the little -1, that's inverse sine. But a lot of people think that it means cosecant because they know that sine and cosecant, you know, like sine of something is 3/5, that the cosecant goes with it, kind of, and then the cosecant would be what? 5/3. Remember this? 5/3. Well, this is not a cosecant. A lot of people think that because they think, oh, inverse, that means like flipping, and that's kind of what's happening here. But that's not what it means. Okay, so that's the main thing I want to get across there is this is not cosecant. And if you saw like, you know, cosine, inverse cosine of something, that does not mean the one that goes with cosine, which is secant. It does not mean secant. Totally different. Okay, so what does it mean? Well, to give you kind of really what it means, we got to go back to what does sine mean in the first place. Sine means opposite over hypotenuse, right? And so if they give you sine of 2 pi, they're either giving you the angle or they're giving you the sides. Remember how this is where the angle goes? This is where the sides go? Like you might say 4/5 or something on that. And they might have said like 30 degrees on that. Or the angle can be in radians too, but they're either going to give you the sides or they're going to give you the angles. And this one, what did they give you? Sides or an angle? An angle. Because 2 pi, do you remember what degree that is? 360. So this is like saying sine of 360. So they gave you an angle, and then they want the sides of the triangle that would go with it. All right, this one. Did they give you an angle or did they give you sides? They gave you sides. And so you could figure out what angle that would be. All right. So you've got to know these reference triangles, 30, 60, 90, and the 45, 45, 90, inside out, backwards, sideways, sometimes even with different numbers than normal in this part of the unit. So would you please draw me these reference triangles? One's supposed to be more like a 30, 60, 90. One's supposed to be more like a 45, 45, 90, and put the sides on them. Like 1, 1, square root of 2, that kind of thing. See if you remember the right place to put them. All right, hopefully you remembered that the one that's got two angles that are the same, those are 45s. And that's the 1, 1, square root of 2 deal. Remember that? The other one, 30. 60, 90, and this is a 1, and then it always was tricky for me to remember which of the other two was the 2. Which one is it? Hypotenuse. And then this one's square root of 3. Okay. Really solid on that? No question on that? Okay, so what if we change this to be like a, I said, okay, well normally that's a 1 there, but now I'm going to say it's a 2. What would you do next? This would be 4, and then 2 root 3. Good. And effectively what we just did there is we can always put our original numbers back on there and say it was 1, 2, crap, hold on. 1, 2 square root of 3, but I times it by 2. So I got to times this by 2 and times this by 2. Can you get that? All right. So if I made this an 8, then I could say, well, I just did times 8, times 8, times 8. 8, 8, and the 8 root 2. All right, do you remember what to do if I changed that right there to a 7? It used to be the square root of 2. Yes, these have a 7 in them. Over root 2. Okay? All right, back to unit circle. All right, if it's truly a unit circle, how long is this? 1. And then the other two must be, well, remember that deal we just did seconds ago? It would have been 1, 1 square root of 2 because of the way this thing is shaped. It's 45, 45, 90. So therefore, I could say, well, to make this root 2 into a 1, I go divide by what? It's root 2. See how that turns into a 1? And then I divide this by root 2, and I divide this by root 2. Remember that? Okay, next thing. People in the back row, wake up. Thank you. All right, this one, I would never actually see as 1 over root 2. I would see it as root 2 over 2. Do you remember that? That's called rationalizing the denominator. When I go root 2 over root 2 and I actually multiply by that, I end up with root 2 over 2. And this one will be root 2 over 2. Okay, a lot of little things to remember. So do you remember if this is x and this is y, and this is 1, and this is theta, then what's sine of theta? Sine, come on, what's sine? Y. Y over 1, which is y. And then cosine is what? X. And then tangent is y over x, which is also known as, since y is sine, tangent is sine over cosine. Okay, just doing a quick review, all that stuff. In this big unit circle where all of those things come back, remember we just saw these numbers a second ago. Remember the waves in here? If I'm looking at sine, remember sine's the y, right? So sine is going up from 1/2 all the way up to 1. And then it starts going back down again. The sine's the y, is why I'm circling these. And the sine ends up back at 0. My alignment's off here a little bit. And then sine ends up going down in the negatives and ends up at -1. And then sine cycles back up towards the positives and ends up at 0. So sine is going up and down between 1 and -1. Okay, because if you look at the graph of sine, remember it goes like that. It starts out going up, goes down as low as -1, and then it gets back up to 0. And that's what it just did. Okay. So, I hope some of these things are coming together better for you. Now, pi over 6, I had you memorize what degree that was. Remember that one? 30. If you had forgotten it, you better write these down now, because we're going to be hitting a lot of these where it's going to be like, what's the tangent of pi over 4? And you'd be like, I don't even know what pi over 4 is. So you might want to make this little list for yourself. Please, right now, with your pencil, on your paper. And this one is 45. Good. 60 is correct. 90, 180, and 360. Those are all the big ones. Now we can't expect you to do sine of 27 degrees in your head, but we can expect you to do sine of 30, or sine of 45, or sine of 60, or sine of 90, or sine of 180, or sine of 360. All can be done in your head. I'll remind you how in a minute, but you need to know all of those. So this is radians. This is degrees. Okay, moving on. So katoa had as its kind of like evil twin. Do you remember that little saying? Well, sine goes with what other thing? Cosecant. Cho. And remember, it's just a flip-flop of these two. So what's the next one? Sha. And cow. Okay. Learned a lot of stuff. Here's another thing you learned. All students take calc told you something important. The all thing meant what? All of them are what? Positive. There you go. And this one's sine, and sine is positive there. So what could you say about cosine and tangent in there? They must be negative. So if I told you, for instance, I want a spot where sine is negative and cosine is also negative, I could say, oh, okay, it can't be here because sine's positive. It can't be here because sine, everything's positive. Sine and cosine are both negative. It's got to be in that spot. Because this was a place where cosine is positive, so that couldn't be it. Remember that? Okay, man, there's so many things to remember. We've got to be able to use all of those things as we move on to this next stuff. All right, draw a triangle or a unit circle if you can't draw a triangle. All right, so how am I supposed to draw a triangle of this? Well, first of all, I got to know where it is. Pi over 6, just 2 seconds ago reminded you of that. That's what degree? 30, so it's like a 30-degree angle. You know where that would be? Hopefully you know. Oh, it's right there. That's where a 30-degree angle would be. Would you please sketch that right now? And now sketch me the rest of the triangle. If you know that's 30, you know something else is 60, you know how long this one side is, you know how long the other side is, you could write all that stuff down. You're going to have little pictures of triangles all over your paper for the whole rest of the year. So we got to be good at these. All right, so if this is 30, then that's 60, then that's 1, and that's 2, and that's the square root of 3. That's what I was going for there. Is that what you had? All right, so what is the answer? What is the sine of 30 is another way to think of it. Sine is opposite over hypotenuse. That over that, 1/2. See, they gave me an angle, and what did they want? They wanted the sides, and there they are. Okay? Give me a 5, 4, 3, 2, 1 on how comfortable you are so far. 5 being like I'm really good. All right, that's 5s and 4s. That's good. Okay. Then if I did secant here, there is no, like, you know, I guess there is this Choshakao. But if I really didn't want to do secant, but I want to do something else, I could, and then I had to flip my answer. Remember what I'm talking about? Okay, so if I wanted to ask you secant of this, my first thought would be, I'd really rather do secant of 60 degrees. Isn't that an even swap? 5 over 3 is the same thing as 60? It is. So they gave me the angle, right? And what do they want then? They want the sides. See, they gave me an angle, and they want what this is. What's over here, those are supposed to be a sides in a fraction. So would you please see if you can figure that one out? And if you can't do secant in your head, then figure out cosine and then flip it. All right. So if I was going to draw a triangle, remember, I wouldn't be trying to do this with a triangle. You're going to draw triangles all over the place. I'd start with one of these, and I'd say, all right, well, I know where 60 is. It looks like this. So there's the beginning of my triangle. Alignment's off. Sorry about that. Make a big x-axis for this. Okay, so now secant, okay, 60. If this is a 60, then this has got to be a 30. And this is a right triangle, and this is a 1, 2, square root of 3. And then I can go secant of that. Well, normally, I don't like secant. I'd really rather do cosine. Cosine of 60 would have been adjacent over hypotenuse. It would be root 3 over 2. But then I got to flip it. So my final answer is? Oh, did I do something wrong? Cosine. Cosine is adjacent over hypotenuse. I just did opposite over hypotenuse. Dang. I just did the opposite of hypotenuse. I shouldn't have. Cosine is adjacent over hypotenuse. There we go. 1 over 2. Then you got to flip them. So it's 2 over 1. Raise your hand if you had that one right. Okay, good. All right. This one I want you to just think about for a second. What is 2 pi? 360. You know what the answer is? 0. Now, if you don't have that one memorized, how could you have gotten it? Well, I know sine looks like this. Sine goes like, starts out at 0, goes down, and comes back up again. It ends right there at what? The answer is 0. Now, what if I don't have that memorized? I forget that there's a graph for it. Well, then I could make the little unit circle dealy-bob like this. Always start with one of these and say, where is sine of 360? Well, it's right there. There is no triangle. It's a straight line. It's a flat line. So then there's a point there. What point is there? 1, 0. And then what is sine? The x or the y? The y. And that's how I could also figure out that the answer is 0. Okay? Because 360 goes right over here. And that's a point over there. There's no triangle because it's flat. All right. I'd like you to draw me a triangle for that first one. Remember, I've given you 2 sides, so that means I want to know what the angle is. Not saying you'll be able to do it in your head real easy, but just set up the triangle for me. Okay, so I'm guessing you figured out that, okay, that you probably can't figure out the number of degrees in your head. But maybe, we'll see. Maybe I'm wrong on this. But all right, so sine means, well, I got some triangle. And it's positive. See, notice there's no negative in that? So therefore, sine's positive in this spot. So I'm going to draw it right here. And sine is opposite over hypotenuse. And if that's a 4 and a 5, do you know what that one is? 3. Good. So at least we know what the sides are. But do I know how many degrees it is? No, it's not one of the ones I had you memorize. So how on earth do you do it? You can't do it with a triangle. You got to use some algebra. You know when you had to solve like 2n equals 18 and you get rid of the 2 by doing the opposite of times 2? And you go divide 2, and the answer is 9? Well, same idea. What if I had n plus 3 equals 2, no, let's say 21, then I'd subtract 3 from both sides, because that's the inverse of this. The inverse of positive 3 is negative 3, or plus 3 is minus 3. So, really what we want to do is get theta alone. How do I get theta alone? I got to get rid of sine. How would I do that? Inverse sine. You get that? I'm doing inverse sine on both sides. So I'm going to move this 4/5 over here and say inverse sine of both sides. See, there's one here, there's one here. I did it to both sides. That's what you do on all the other solving equations once. And so this and this will cancel, and that leaves me theta is equal q. Theta is equal to, sorry about the noise there. That. And how am I going to get that? With a calculator. Grab your graphing calculator, please. Inverse sine 4/5, you get a nice simple answer. And when you're allowed to use calculators, it's a beautiful thing. You can get the answers so quick and easy. If you need to borrow one from me, please do. There's one on my desk. There's another on my desk. Good question. If you do it in radians, you'll get radians. That's a good enough question to... Yeah, I am recording. Good. Okay. So if you do it in radians mode on your calculator, and your answer is in radians. But if you're fresh off of the MCA test, you probably had your calculator in degrees, right? So therefore, if you do this in degrees, your answer is in degrees. So how many degrees is it anyway? 53 degrees approximately. All right. Same idea here, except it's trickier because there's no inverse secant button on your calculator, is there? So you have to know what to do. You have to think, okay, well, since I can't do secant, I could change this problem into cosine and rewrite it as cosine of theta, and then I got to flip that, negative 3/5. Couldn't I do that on a calculator? Yeah, you do inverse cosine of both sides. Don't forget the negative. Inverse cosine of negative 3/5, and what did you get? Inverse cosine, negative 3/5. Theta is 126. Point something around 127 degrees. Oh. All right. So now, what I did there on both sides was cosine negative 1, cosine negative 1, inverse cosine of both sides. All right. So now, if you can use the calculator, these become super easy, and that we talked about just right a second ago there. So if I was going to convert this to inverse notation, all they're asking you to do is rewrite the problem so you got an inverse sign in it. Well, to do that, I'd have to put inverse sign on both sides. Sine of negative 1 on both sides. And then this will cancel this. So my final answer would just be to say, there, I've converted it to inverse notation. You don't even have to, like, what if there was a part of the test where you couldn't use a calculator and yet you were supposed to do this? Well, then you just have to leave it like this. because you don't know what the answer is, but you know the answer is theta is equal to, okay, so all I did was put inverse sine on both sides. So what do you think I'm going to do on this one? So both sides. Inverse cosine. And my final answer will be inverse cosine of negative 4/5. And if it's cosecant, I can't really do cosecant, so I'm going to change it to a what? A sine problem, and then I got to flip it. Sine of theta can't be 2, but it would be 1/2. And then I could do my inverse sine deal. You know, no such thing as inverse cosine, at least not on your inverse cosecant. I mean, not on your calculator. So to finish this one off, you go inverse sine. And the final answer after these cancel is theta is inverse sine of 1/2. There. Okay. Remember, they're going to either give you sides or give you an angle, and you got to figure out the other thing. These get confusing sometimes. It sort of looks like they gave you sides. Do you get that they really gave you an angle here? It's just that it's in what? Radians. It's in radians. Okay? And so if they gave you an angle, then they want what? Sides. So it's a lot like if they had said cosine of 45, and then they wanted to know what the sides would be, something over something. All right? Here's one. Think now. Did they give you sides, or did they give you an angle? All right. Here's the way to think of this. Before this problem turned into this, it would have had a theta in it. Do you see what? Do you get what I mean there? It doesn't have any variable right now. So it would have been like this. And then how did they get this inverse cosine? Probably because they did inverse cosine to both sides, right? Do you know how I can get rid of the inverse cosine? Cosine of both sides. And notice what happens. Its cosine of some angle is equal to 2/4. Do you see that they actually gave me sides? And then they want to know what the angle is. Anytime you see this, they are giving you two sides. Okay? They've given you the sides and they want to know what the angle is. That's kind of an important thing I just said. Anytime you see this, they gave you two sides right here. All right. Arctan. What the heck is that? Any guesses? It's not an arc. It's not like a part of a circle. No. Yep. Yes. Arctan means tan to the negative 1. Very good. So this is exactly as if they had said this. Now again, I ask you. It's just another way to say tangent or inverse tangent. Arc and inverse is like you can they're interchangeable. Okay, so if it says arctan, you can say inverse tan, same thing. All right, now, did they give me sides or did they give me an angle? Last time, just seconds ago, I had a problem just like this, and I said that when they had this, they gave you two sides. They did. They gave me two sides here, and so they want to know the angle. All right. Notice I changed the 7 into a 7/1 because I need two sides. If they only give me one side, it doesn't help me enough. All right, moving on. Here is a typical problem for today. If you're allowed to use a calculator, you know what to do? It's going to be like a no-brainer, so don't even do it. You're just going to type it in, right? And it'll give you an answer. But did they give you sides or did they give you an angle? They give you sides and they want and the angle. All right, good. That's all you have to do. What if I had wanted to see this written differently? You could put a equals theta here, and then you could get rid of the inverse sign by putting a sign on both sides. This is kind of unorthodox, but it'll work. That'll cancel that. And now I just write what I have. Sine of theta is equal to 4/5. And if you like that better, and you can see better that they want an angle, and that those two are sides, you can rewrite it like that if you want. All right, moving on. Here's another typical question. Would you please actually figure this one out for me? You'll probably have to draw yourself a triangle. No calc, no calc, because if it was calc, I can train a 8-year-old child to do that. Part calc, part not calc. Yes? Then you will have to set up a triangle. And the degrees they would give you would be either 30 or 60 or 45. But it's really always going to, almost always going to come down to triangles, unless there's a calculator involved. All right, so you got to ask yourself, okay, so he's telling me to draw a triangle. Did he tell me the angle? No, he didn't tell me the angle. He told me what? He told you sides. And if this is the angle that I'm going to pick for my situation, cosine, if I told you this, could I rewrite this? I kind of would like to rewrite it. Cosine on both sides, and then that would cancel that, and so it's cosine of theta equals 1/2. Now I feel more comfortable because I don't have that stupid inverse stuff. And now I get that they gave me cosine is adjacent over hypotenuse. They gave me the adjacent side is 1, hypotenuse is 2, and oh, this is one I recognize. 1, 2, and then what's the other side got to be? Square root of 3, and therefore, did they give me the 30 or the 60? That's a 60. The answer is 60. That one must be 60. Raise your hand if you followed that. Okay, good. Then, a third kind of problem. All of a sudden, there's an inverse inside of a not inverse, a normal function. All right, well, what have I tried to teach you many, many times about where to start a complicated problem? On the inside. So act like the sign isn't even here. Just act like it's not there, and then figure out the answer to this. Once I know the answer to this, I'll do the sign of that, but I don't know what this is yet, so I'm going to figure out what that is. Wait a minute, didn't I just do that last time? Oh, so it's, wait a minute, I don't want to have an answer in sides, I want to have an answer as degrees. So do you get that this right here was 60 degrees? So therefore, I already figured this out, it's 60. So it's really sine of 60. Do you get what I just did there? I'm not, just, see, if you jump all the way to the end, nobody knows what you're talking about. Okay, so now, sine of 60, that one I can do with my little triangle. Okay, if this is going to be a 30, 60, 90, I'll make that the 60, and then this is the 30, and this will be a 1, 2, square root of 3, and the sine of 60, sine is opposite over hypotenuse, and it's going to be root 3 over 2. Get that? Maybe I went too fast at the end there. It's sine of 60. I'm going to redraw that triangle a little less messy. 30, 60, 90. 1, 2, square root of 3. Now, what's the sine of 60? Sine is opposite over hypotenuse. So I got to go here, over there, root 3 over 2. Okay? All right. One more like that. See if you can handle this one all by yourself. No calc. Inverse tangent of 5. I bet this is not one of the ones that you're going to have memorized. So I start this here. They've given me sides, 5 over 1. And if I rewrite that, I could say tangent of something would give me 5 over 1. So I want to figure out an angle for this. So tangent, if the opposite side is 5, let's say I'm coming from this perspective. And then I should make it the other way. I should make it skinnier here and tall there. Tangent would be 5 over 1, like that. And then 1, 5, and I have no idea, but I don't have that one memorized. So therefore, you would never have this problem unless you had a calculator. Okay? It's okay to get to the point where you go, no, I can't do that one. The only ones you'll be able to do is if it ever comes out to 30, 60, 45. And if it's a 90 or those you can draw without a triangle. You can do the 90s and 180s and 360s, anything that's that doesn't make a triangle, you know, like these, by saying what point you're at. 0, 1, etc. All right, moving on. There's a twist. Yes, question? Yep, back to this one. Yes, you can figure out that third side, but that's not what I want. What I want is the angle. But you're right, this would be 25, and that would be 1 squared is 1, 26 squared is 26. I agree, we can find out that side, but what we really wanted to know is how many degrees this was, and we can't do it without a calculator. All right, this one. We got a inside and outside, but this one you can actually do. Really easy. Let's see if anybody figures out what's happening here. Oh, who said that? It's just 5. Why is it just 5? Yeah. Inverse tangent cancels tangent. Remember? All right. All right. Slide this down, see what joy we have waiting down here. Can I make those to cancel also? Yeah. Therefore, x equals 5. Okay. Can they keep getting stranger? Yes, they can. Okay, this one's a little more actually normal. You could figure out, remember when you see this thing, you've been given 2 sides, and you want to get an angle. And can anybody do this angle in their head? 30, very good. So then this is really 30. And then it's cosine of 30. And then you go to your 30, 60, 90 triangle, 30, 60, 90, and this is 1, 2, square root of 3. And I go cosine of that. Cosine is adjacent over hypotenuse is that, root 3 over 2. All right. You realize what you're doing now. You're doing functions of other functions, like sine of cosine. All right. What does that mean? Well, first of all, you got to know what arc cosine means. What does that mean? Inverse cosine. So that's like this. And where do I start these problems? On the inside. Here, did they give me sides or did they give me an angle? They give me an angle, so I'm going to want to figure out some sides. Tangent of 45, right? Anybody get that one memorized? Tangent of 45. If you didn't have it memorized, you could draw the triangle quick. 1, 1, square root of 2. Tangent of this angle. Tangent's opposite over adjacent. 1 over 1 is 1. So that's just 1. But wait a minute. I need 2 sides. 1 over 1. I can put this as 1 over 1. And now I've got my 2 sides, and I'm supposed to do inverse cosine. Like how many degrees would it be is what they want to know. All right. I think we're reaching the end of your brain power, and that's good because we're done. Now, you have 25 minutes left in class because these are extremely long class hours today. So now you have a bunch of time to work. 31 questions is too much, so I'm going to pare it down for you. Would you please start by taking out a piece of paper that you're going to do your homework on and writing down a few. Here's what I would like you to do. First of all, I made a conscious decision. There's actually one more thing I could have taught you, and then I'd like, no, that's just too much to try to do in one day. So there are some that we need to skip. We're going to, did it really only say, okay, hold on just a sec. Okay, so we're going to do 1 through 16 for today, and that's all you have to do. That is actually an easy assignment. If you understand what we just talked about there, this should be a snap. Because last year, actually, the assignment was 1 through 31, but we had them skip some, but not this many, so be happy.